All right, so do you remember how we did the tangent lines back in Calc AB? We had something that was linear, and we used it as an approximation. And now we're doing more grown-up ones, and we're saying, well, if it's a polynomial, it's a better approximation. Like if you have something to the second or third or fourth. And then what we call it is a power series if it goes on infinitely, and it will be the actual function itself, like it'll be perfect. Like this is all logically making sense. Okay, so we went from linear to a higher order polynomial to something that's a power series and goes on forever, and it'll be perfect. So the higher the better, or the higher the power, the better the approximation. So infinite will give you the exact function. What we're going to look at today is what's called a radius or an interval of convergence. And I really like this lesson because it's a big review of all the infinite series stuff that we did that you probably have forgotten about. So we're going to review a lot of that, which is good. It's going to tie in. So you have this place where they're centered. And if it looks like this, it's going to be centered at 0, which is most of the time. Otherwise, it'll be centered at some other value C. There's only a certain distance you can get away from that where it's not going to work anymore. And it won't actually give you the exact function anymore. Is this making sense? Like you can only get so far away. And that's what's called the interval of convergence. So your radius of convergence, let me show you a picture. Here's C where you're centered. The radius of convergence is how far away from that centered value are you allowed to get. So this distance is R. That's your radius of convergence. How far away from the center can you get before it's not going to work anymore? So R is that distance. The interval of convergence is like from here to here. So here's the options. Here's the different ways that it can turn out. You might not be able to get anywhere. Your radius might be 0. It might only converge at C. That would be like this. Like literally all you get is C. It's very picky. It will only converge for that value where it's centered. You can't go anywhere. Or you might have some radius of convergence that's an actual positive number. Now, there's 4 ways that can turn out. So draw 4 little graphs. And so you're going to be centered at C. What you have to do is check the end points. So if it converges at both of the end points, then you would have brackets. And this would be your interval of convergence, is everything in between. Or it might converge at one of them, but diverge at the other. So you would have something like this. Are you seeing what I'm saying here? Or like getting where I'm going, like what's the next one? Or yeah, like you can have this one diverge and then this one converge. Or they both diverge. So once you get R, that's how far away you can get. And then you check the endpoints. It's a little bit of work. That's why I left you so much space. This does typically show up on the free response part, but it's not hard. It's just a little bit of writing. I actually kind of like this because it's all going to be stuff that you learned before, and it's going to be a nice review. The way that, oh, sorry. And then the last one, it could converge for everything, which is kind of nice. And you get like the whole number line. So you get R first, that's how far away from the center you can get, and then you test the endpoints. The way that you get R is with the ratio test. So let's review that real quick. Do you remember your last unit test, unit 10? And you had like the alternating series test, and you had P series and geometric. Do you remember this? In the ratio test? It was that limit as n goes to infinity of that like gigantic absolute value. Remembering this? That's how you get R. Okay, so buckle up. Here we go. Limit n goes to infinity. Like I said, it's not hard, but you're going to do a little bit of writing. What went on the top? Do you remember? No, +1 is +1. You do n plus 1. So you plug in n plus 1. This would be n plus 1 factorial, and then x to the n plus 1. I didn't leave enough room for myself. And then in the denominator, you put, yeah, like the series, right? So just copy that over. In your second step, you would do the reciprocal, but this one didn't end up being a fraction, so we can skip that step. In the third step, you look for things that cancel. So you have n plus 1 factorial over n factorial. Do you remember if you listed all that out, it would all cancel all the way up to n, and what you would have left is that n plus 1 in the numerator. And then what about these? You'd have x where? In the numerator. So actually there's nothing in the denominator. You could put it over 1 if you want, but you don't have to put anything. And then the last step was evaluate the limit. So as n goes to infinity, this whole thing goes to infinity. So what we ended up with is that this diverges, which means you don't have a radius of convergence. Like it's going to be 0. You can't go anywhere. R is 0. So this is that situation where it's super picky and you're stuck at the center. So your interval of convergence. Now I made this deal with my class last year and everybody was on board. So that we don't have to write interval of convergence over and over and over again. Can we write IOC? Okay. So this is what we're going to use for interval of convergence. It would just be C equals 0. It's just where you're centered. And everyone's usually like, how do you know it's 0? How do you know it's not centered somewhere else? Look at the original problem. Do you see how that's just an x? Like it's not an x minus 5 or an x plus 2 or something. Do you get what I'm saying? It's 0. Most of the time there's 0. Okay, so that's what it'll look like if your radius of convergence is 0. I'm going to skip around here. We're going to do number 4 next. So go ahead to number 4. All right, so limit n goes to infinity. Big, huge absolute value. Now, because we're absolute valuing this, we can leave off that -1 to the n. That's just the part that's going to make it alternate. But since we're going to do absolute value, you can just ignore that part. Does that make sense? Just leave that off. So we're going to plug in n plus 1. Now, if you plug in n plus 1 for n, it would look like this. And you can just look at what I have written. Do you see what I did there? Okay. That would give you 2n plus 2 plus 1. So it would be 2n plus 3. Algebra is fun, all right? So x to the 2n plus 3 over 2n plus 3 factorial. And then on the bottom, you're going to just copy the whole thing over. Again, without the -1 part. And do you guys remember how I suggested make the fraction bar in the middle, like touch the absolute value? So you can kind of tell the difference of what's what. Otherwise, you just end up with a bunch of lines everywhere. Yeah. Okay, cool. All right, so limit as n goes to infinity. Your next step is that you're going to reciprocate. So we're going to flip this denominator over. So up in the numerator, you're going to have this x to the 2n plus 3. And then also this 2n plus 1 factorial. And then the stuff in the middle, do you guys remember me circling this? Like this stuff will go in the denominator. And you want to kind of line it up. Like I'm going to put the x first. And then the 2n plus 3 factorial. Because now we're looking for stuff that cancels. Do you see why I left you so much room? All right, so now we're going to look for stuff that cancels out. Oops, that's a really bad. Yes. Can you explain how you got that? Because I was going to talk us all through that, but you just like said the answer. So yeah, 3 minus 1 is 2. If you do 2n minus 2n, those are gone. 3 minus 1 is 2. Are you good? That just kind of spits that out. So you're subtracting these. So 2n minus 2n goes away. 3 minus 1 is 2. So that's all that's left there. Now, this one, let me talk you through that. You know how if you do 5 factorial, it's 5 times 4 times 3 times 2 times 1 the whole way down? All right, if you do 2n plus 3 factorial, and you can just watch me write this, it would be 2n plus 3 times 2n plus 2 times 2n plus 1 times 2n. Do you get what I'm saying? Like, that's how it's going to go down each time, like going down by 1. So it's going to cancel up to the 2n plus 1. Like, all of this would cancel all the way up to the 2n plus 1. So these are the ones that are left. Come on with me there. Okay. So this is gone. In the denominator, we've got these two things. And your last step is you evaluate the limit. So as n goes to infinity, down here, these are going to infinity. That means the denominator gets bigger and bigger and bigger and bigger and bigger. So what does this whole thing equal? 0. And do you remember how we tell for the ratio test? Like the first one we did, it came out to infinity, so we know that diverges. But the way we tell is whether this number is bigger or smaller than, oh, good, nice job. Okay, 0 is smaller than 1, which means this converges literally all the time. It means it's just good. It's just going to work. We're good. So your radius of convergence is infinity, and your interval of convergence is the entire number line. So I did the two kind of weird ones first. The first one we did was where it was just where you're centered. This one came out to work all the time, so it's like literally everywhere. The other ones we're going to do are going to be like more specific numbers, like you're going to have a range of numbers. Is this making sense? I can't give you a break. We got to keep going because I want to make sure we finish it. I will skip number 2. We'll go straight to number 3. 2 and 3 are pretty similar, but I am going to do the rest of them. I'll do 3 and then the rest of them. All right. So start with your limit as n goes to infinity. We're starting with our ratio test. So you're going to plug in n plus 1. And then that goes over the series itself. And then we're going to reciprocate it. So in the numerator, we'll have x to the n plus 1. And then what else? What else will go up to the top? N. This stuff in the middle stays on the bottom, but just try to line it up. It'll be x to the n, and then times n plus 1. Again, I like this lesson because it's basically a review of Unit 10, which I know probably forgot about. Then you're looking for stuff that's going to cancel. So for those x's, you're going to have 1x left, and it'll be where? On top. Nothing else is really going to cancel though, so you can sort of just leave the rest of that. There's really nothing you can do with those n's. Last step is you evaluate the limit. This is n and this is n. They're both n to the first. When it's a tie, you use the coefficients, which would be x over 1, which is just x. So it came out to just x, absolute value, and this needs to stay smaller than 1. So this is n and this is n. When they're the same, you use the coefficients, which would be x over 1, which is just x. So your radius of convergence is 1. And this is centered at 0. And the way I know it's centered at 0 is I don't see any other numbers in here. Like you don't see a x minus 4 or anything. So it's going to look like this. We're centered at 0. And we're allowed to go 1 unit in each direction. But I don't know if these get brackets or parentheses. So here's where you have to test the endpoints. I know you're like, but we worked so hard already. Yeah, you're not done. You got to test the endpoints, okay? So first, let's do -1. You're going to take -1 and plug it in for x. in the original series. Are you seeing where I'm pointing there? Okay, so it's going to be sigma n equals 1 to infinity, and I'm going to plug -1 in for x. And you have to decide if that converges or diverges. Now, they usually turn out to something pretty easy, like a p-series or a geometric, or in this case, it's alternating. Do you remember the alternating series test? There's 2 parts to it. First, you do I just can't hear what you're saying. Did you say limit? Okay, good job. I don't think that's what you said, but I couldn't hear you. You would do limit as n goes to infinity of the thing. That needs to come out to 0, which it does. And the second part is you have to show that the terms keep getting smaller and smaller. So if you plug in n plus 1, is that smaller than just with n? Like, is this true? Yes, because the bigger denominator is the smaller fraction. So we would say converges by alternating series test. Again, I know you guys don't like it, but I like this lesson because it's reviewing so many things. So I know that -1 is going to get a bracket. So we tested that one, it converged, we're good. Now we're going to test +1. So you're going to take +1, plug it in for x in the original series. That's just going to give you 1 to the n in the numerator, which would just be 1. So it's going to look like this. So what do you guys think about that one? It's going to, well, that's the other option, isn't it? Diverges because what's 1? What kind of series is it?
P-series.
Oh, and it's
I kept saying over and over again.
harmonic is a p-series. It's a very specific one. I'm surprised you remember. That's awesome. Diverges because p equals 1, which is less than or equal to 1. They'll accept diverges because harmonic series on the AP exam. They will accept that. All right, so 1 gets a parenthesis. So your interval of convergence is bracket -1 to 1 parenthesis. I have time to do the last 2. We'll finish them. I promise. Because one of them, I'm going to show you what happens if it's not centered at 0, if it's centered somewhere else. And one of them, I'm going to show you if this doesn't turn out to be 1, how you do that. And that's what I was saying. I need to do all of them basically because they're all a little bit different. So hang in there. Limit n goes to infinity. Gigantic absolute value. So we're going to plug in n plus 1. This would be 3x minus 2 to the n plus 1, and then over the series itself. Sorry, that didn't look very pretty. I'm going to fix it. Now, normally you would reciprocate, but there's nothing to reciprocate because there wasn't a fraction. And then you would look for things that cancel. So that's the step that we're on. So what's going to cancel here? Yeah, the 3's are going to cancel. And then all of the x minus 2's, except for one of them. Yeah, so that's all you've got. So then you would evaluate the limit. Its limit is n goes to infinity. And there aren't any n's. So it's just going to be absolute value of x minus 2. Like all the n's were gone. And then that needs to be less than 1. That's what the ratio test says. It has to be less than 1. So r is 1, which it is usually going to be, because if that's 1, like, again, the last example, I'm going to show you how it turns out if it's not 1, but like usually that's going to be 1 because that's like the rule. Okay. But now this one's not centered at 0. Where is this one centered? 2. And if you're allowed to get 1 unit away in each direction, what are your endpoints that you have to test? 1 and 3, perfect, good. Do you see how you have to do a bunch of them to get the hang of it? Like I can't just do one example and be like, okay, we're done. All right, so let's test 1. You're gonna go back to the original series, plug in 1 for X. So that is gonna give us sigma n is 0 to infinity. If I plug in 1, that would be 3. And then what would you get here? Yeah, -1 to the n. What that's gonna look like is 3 minus 3 plus 3 minus 3 plus 3 minus 3 plus 3 minus 3. What do you, does that converge? No, that's gonna diverge. Not really for any particular reason. I don't have like a because for that one. Because this, like it's just not headed anywhere. All right, and then we're going to try 3. So you're going to go back to the original series, plug in 3. That's just going to look like that. Because 3 minus 2 is 1. So you don't really need to write that part. So what would that series look like? If you started to list them out, it would be plus 3 plus. Okay, so what's that going to do? Yeah, that diverges. It's just going to keep getting bigger and bigger and bigger and bigger and bigger. So your interval of convergence is 1 to 3, and they're both parentheses. So that's what it'll look like if it doesn't converge at 0. We'll have that x minus 2 in there that tells us that the center is 2, and then you go 1 in each direction from there. Let me show you what happens if it doesn't turn out to be 1. And the way I can tell already that R is not going to be 1. Actually, let me ask you, what do you see in the problem? Because of the 4 that's with the X, it's not going to end up being 1. Okay. You guys are awesome. You like listen to everything. You remember everything. You like notice stuff about the problems. It's awesome. Yeah, you do. Well, you try and you succeed. It's awesome. All right, so plug in n plus 1. So it'll be 4x to the n plus 1 over n plus 1 squared. And then in the denominator, you're just going to copy that over. Well, and I super appreciate you guys today because I feel like I'm pushing you kind of hard today, but this wasn't a topic that I wanted to sort of gloss over. Like this shows up on the free response. And it's worth a boatload of points, and you can get them all because if you just know the process, you just go through and write it all out. All right, so now we're going to reciprocate. So on the numerator, you'll have 4x to the n plus 1, and then also n squared. Good. And then all this stuff goes on the bottom, but just try to line it up. And then we're going to try and cancel some stuff. So all the 4 x's are going to cancel except for one of them. It'll be on the top. And then you really can't do anything with the n's. It's just going to stay n squared over n plus 1 squared. Because if you were to like expand out the n plus 1 squared, that would give you n squared plus 2n plus 1. And just like you can't cancel the n squareds like that. It just, sorry, that's such a crap answer. It just won't work. Like it just mathematically will not work. You usually can't do anything with the n's, just kind of stuck with them, which is good though, because when you go to evaluate the limit, this is an n squared and this is an n squared. And when they're the same, you use coefficients, which is 4x. So you end up with this, and it needs to stay less than 1 because that's the rule. What's the absolute value of 4? 4, and you would divide that over, And so R is 1/4. And so that's how it'll look when it's not 1. Because usually people are like, well, how would R not be 1? Like if it's the rule that it stays less than 1, R would just always be 1, right? Well, if you stick another number in the problem, then it alters it. Now still centered at where? Where's our center? Yeah, 0, because you didn't have anything like added or subtracted. There wasn't like a shift. And then your endpoints, instead of 1 and -1, it's 1/4 and negative. So we're going to test those to see if they get brackets or parentheses. So let's plug in -1/4. Look at the original series. If you plug in -1/4 right here, what's that going to give you? -1 to the n, good, over n squared. And what test would you use for that? AST. For the sake of time, it's gonna work. If you do the limit to infinity, it'll go to 0 and the terms will keep getting smaller. So converges by alternating series test. So -1/4 gets a bracket. And then if you go and plug in +1/4 to the original series, what are you going to get? If you plug in +1/4 for x, 1 to the n, which just is 1, 1/n squared, how would we deal with that? Or what type of series is it, I guess, because it's not alternating anymore. P series, where P is 2, so it converges. So converges because P equals 2, which is bigger than 1. So that also gets a bracket. So your interval of convergence is bracket -1/4 to +1/4. And I kind of wrote too big there, so